Great. Let's get started. So welcome everybody to this webinar on how to use agents to build a multimodal data pipeline. Start off with some brief introductions. So I'm Oscar, one of the solutions engineers over here on the Oncord team, and we are very lucky to be joined today by Fred. Fred, would you like to introduce yourself?
Hey, yeah, I'm Fred. Yeah, very happy to be here. I'm the lead. As you said, I have been working with both like generative AI and explainability for quite a while before joining Uncode. Yeah, now I'm here. We are in a really exciting time, and so yeah, can't wait to get started here, Oscar. Thanks for having me.
Absolutely. No, thanks for joining, Fred, and thank you everybody else for attending as well. For those of you who don't know, Oncord is a data development platform that essentially allows you to manage, curate, annotate, and then evaluate your model performance, all oriented in your training data. So essentially, we manage everything on the data development pipeline. And today we're going to be focusing on the automation side of these flows. So we've got a really packed agenda. We want to start off by looking ahead, and we want to look at the future of AI and two key themes in multimodality and agents, the problems with developing these agents and the multimodal side of that, and then the solution. So we'll finish off with a demo from Fred of how we can go about automating this stack. So let's get started. Firstly, we want to talk about multimodality. So Fred, can you please start by telling us what we mean by multimodality and why it's important?
Yes, for sure. Excuse me. Yeah, both you and I, Oscar, we just came from NeurIPS, and which is a big machine learning conference. It was in Vancouver this year. Very exciting to see all the stuff that's going on. And sort of one of the themes that we saw that is very pronounced these days is the theme of multimodality. And so, as you said, like, why is this important? Why do we care about this? So first of all, there's this sort of I think almost like known by anyone by now, example given by Jan LeCun, who basically says that so all these LLMs that we have seen out there, they work on text by default, and text is sort of very low bandwidth. So he does this sort of back of the envelope computation here, where he basically says that you can roughly read 12 bytes per second when you read text, and that's kind of low as compared to when you just look at the world with your eyes. It's much more high bandwidth. I forget the exact approximation he does on how much that is, but it's like multiple orders of magnitude. I think at least a lot more. And so the question now is, can we leverage that also when we're doing machine learning? Is there some way where we can use more information than just the text to do LLMs, for example? But also we will also see some other use cases where it actually makes sense, where there is some information that you can just not draw from the text alone or from images alone, I suppose. So that's why like multimodal is extremely interesting. And yeah, as I said, NeurIPS, we saw a lot of companies asking about how to deal with these multimodal use cases. So a really exciting time, and you probably meant like sort of run into these kind of problems already. So when you use GPT now, you can drop an image or document an audio file. Same with Gemini and many other of these sort of proprietary models, and they can understand them, right? And there are other tools that can also embed them. I think 12 Labs is a good example here. Furthermore, there are companies who understand how to generate all sorts of modalities as well. We know LLMs for generating text, but there are also, Sora that generates video, and a lot of competitors there, Pika, and there's also OpenSora, and just to name a few. Same goes for audio, right? And so all these different models, they have somehow, in one way or another, been trained on multiple modalities all at once. So text and image combined, text and video, maybe even more modalities all at once. So extremely exciting, and it's definitely a trend that's picking up quite fast.
Yes, absolutely. That definitely was one of the key takeaways from the NeurIPS conference, and I can see you're sporting one of the Encore baseball caps as well. But it was really interesting to speak with people from all sorts of backgrounds and essentially all facing a similar problem. That basically they want to be able to add more context, more understanding, a better general interpretation of their problem space by fusing in these modalities. So whether that's adding in transcriptions into their audio speech model, or that's kind of fusing in vision data. And basically, all of these different problems were across the same stack, which was the data layer. And so maybe let's zoom in onto one of these. So if we're looking at a specific example for a vertical of why this multimodal context is interesting.
Yes. Yes. So think about surgery, for example. Um, if you are traditionally, developing maybe a robot that can do assist with some piece of the workflow, which is sort of the the work of doing a surgery, then you would typically be able to read just the sensor data from the robot. So what is the angle of the arms and these kind of things. Um, but that doesn't really tell you how tense is the situation, for example. What if you could also listen to the audio and hear the sort of the voice of the surgeon? Or what if you could look at a live video feed and actually see how many people are standing around this person having the surgery? Um, Maybe you could look in the patient history to sort of be better in terms of knowing what would be the potential or likely uh, uh, I guess disasters that could happen. If is this someone prone to heart attacks or something else? All this information is sort of something that will basically help the system become better. And so this is like just one example of why multimodal data is so important. But there are also more quote unquote simple use cases, right? It could just be the understanding of videos. If you are, some technician that is working in the field, you have these VR glasses, and you're trying to understand how to fix this particular engine. Then, what if you could understand the document, the sort of technical document associated with the engine, and could sort of also understand the video feed from the glasses? That would give you a much richer interaction. And so there are many of these examples, of course.
Absolutely. I mean, even from a human learning perspective, just to think how much we can derive from communicating with other people when we have vision as well as audio, it's just something that seems really nice and intuitive. But having, for example, textual information where most of our historical context is generally stored, I think, in enterprise use cases, then being able to fuse this in as well seems kind of super valuable. So Fred, would you mind talking us through the different ways these modalities have been fused together previously and kind of maybe on the more cutting edge side, how they're being done today?
Yes. So I think if we start in the lower left corner, um, traditionally what we saw with, for example, recurrent neural networks was that you would use this recurrence, or you would reiterate the network many times on different data again and again to sort of compound or build up some sort of an embedding representation of the data. And this has some nice properties, which is that it can be run relatively fast. But it also has some annoying kind of biases that you impose on the model, which is you need to look at it in a particular order, and there's no real mechanism to learn sort of very long, like things that are very long from each other. In, for example, a piece of text or between the image and the text will be hard to sort of learn the relationships. And then one day came in the transformer models. These transformer models, they came with this idea of attention. And in particular, in this case, what we care about is cross attention, which is essentially a mechanism for the model to learn how to fuse data, or like coordinate the data flow between different modalities. So in this figure we see here, um, by seeing a lot of data and solving sort of relevant tasks, the model can learn itself what to attend to in both in all the different modalities. So in this particular case, if we look at the sun, these transformer models, they will eventually learn how to look at the sun in the image or the sequence of images, but maybe also hear someone telling about the sunrise, or whatever it is that gives some additional information from the acoustics. So that is really the power of these transformer models, that they can do these cross attentions between domains, and it's extremely cool, I think. And that we have that sort of previous webinars where we talked about exactly how this works. For example, in LLMs. So I'm not going to go into detail with that here, but yeah, it's just like this idea of being able to fuse information and coordinate it with very few sort of architecture biases, which is really cool.
Very cool, very cool. And rather than having kind of a data scientist go through and do this manual fusion, being able to have the models do this themselves is obviously great. And then, moreover, if somebody is working already with an existing modality, the ability to use this coordination approach to bring in new modalities also means that you don't have to kind of rip up your existing model pipeline, and it's something that kind of be done in an additive sense too, which is great.
Yeah, there's maybe one caveat to attach here, which is this requires a lot of data. So if you want to like not do any feature engineering where you can use as an ML or data engineer, you can use your intuition about how things sort of add up, then you'll just need like more data, much more data. So that's sort of the caveat here.
Mm. So yes, you might save some time and some personnel expense by not having to have your human give the context to the model by doing this feature engineering, but we need a lot more data in order for the model to be able to extract this itself. That's super interesting. Um, and so I think we'll leave multimodality there for a moment, and we'll think about the future of AI as discussed. We also want to talk about agents. So we've discussed this multimodal problem where we want to use different data flows to basically imbue a better understanding onto the world. But then we have this idea of agents, and agents are a bit of a zeitgeist in the AI space at the moment. Seeing agents everywhere. So, Fred, when we say agents, what's the kind of difference between a traditional ML system and an agentic one?
So usually what we think about when we think about agents in this context is systems that are able to reason and maybe even devise a strategy or a plan and then actually execute the plan as well. So you could think about, for example, Anthropic, they recently released this new feature where they allow Claude to actually use your computer. So if you do this integration thing, it can actually click with the mouse on your screen and sort of perform tasks on your behalf. So that's what we would think about as an agent. And again, this is sort of a thing where it requires so much information and so much understanding of human intent that it requires like a lot of data before you can reach to these kind of capabilities. Yeah,
absolutely. And I mean, the kind of the business benefit and the market is huge for these, as we're seeing very large funding rounds coming up and a very broad range of contexts occurring across these. So this traditional sense of agents, we're seeing kind of like we're seeing these web agents or these VLM agents you've discussed. And so we're seeing these act across a bunch of different spaces. And yeah, this data problem seems to be pertinent for basically giving the agents the information that they need to be able to perform these actions too.
Yeah, for sure. So as you can see on this slide right there are so many attempts or so many different solutions to building these type of agents. And each and every one of them, they require a lot of data because it's not just about having it, follow your like a simple instruction. It's typically tied to a very particular problem. You can, for example, see in the upper left, there are a lot of coding/application generation agents. And what they try to do is essentially automate your coding efforts as much as they can. And this requires that the agent sort of sees a lot of examples of, web pages that you're trying to get at. So there would typically be a lot of data where you have web pages and descriptions of the web pages, and maybe even web pages before and after and descriptions of how would you like what is the sort of the query to alter the web page? And so all these different agents, they require a lot of very specific data in order to make them actually work properly and sort of align with human intent. Um, yeah, I think if you're interested in this, there's actually one of the Lex Friedman podcasts with the Cursor team with this code development uh, fork of VS Code. It's really cool. They have some quite cool ideas in this one.
Very cool. Absolutely. Again, I think think how much kind of domain specific information lies both in the horizontal and verticals of all of these pieces. There's so much understanding when a human carries out these tasks that they have to be able to impart this into an agentic system. There is so much data that we need to be able to process and give a kind of semantic understanding to. So previously, we used to be able to work with data for these non-agentic systems, and it was kind of a simple unimodal task. But then, as we've discussed and we've looked at, when we're moving forwards, we need to be able to bring together these modalities in a kind of structured way to be able to perform actions onto the world. So for both the multimodal problem and the agentic AI problem, essentially this data bottleneck is what is preventing us advancing in these fields.
Yes, that is exactly it.
So
And I can't stress enough how exciting the times are we are in right now. 2 years ago, we wouldn't have imagined what was possible. It seems completely out of this world what we can do already. And I guess this is just the beginning. So yeah, really exciting times. But there's this big data bottleneck to be solved to actually, yeah, really be able to harness it.
Absolutely. So what's wrong, I suppose, with the previous data pipelines that we had for addressing these new issues that are kind of moving forward on the bleeding edge of AI?
Yeah, so I think it's sort of back to one question I answered really excuse me poorly. So you asked me what is the difference between traditional machine learning and now all these new agentic systems, right? And it's kind of the same thing here. Sort of traditional machine learning, it had one particular problem in mind and only had to perform well on that particular problem, very sort of scoped. And that meant that we could build these sort of very single task supervised learning solutions with, a clear evaluation, a very clear data pipeline, very clear data transforms. And now, because we want to be so general and applicable to sort of a sort of more complex world, it also just means that everything is going to become more complex. So that means that we have to somehow figure out a way to disentangle and sort of isolate some of the responsibilities, at least in order to be able to, comprehend the entire system. And we also need to, bring in models as much as we can. So it's kind of a sort of a cyclic argument here, but we're actually going to use a lot of multimodal models or agents even to build these systems, because if we don't do that, we just can't scale. I think we heard recently that Ilaria, he from like a former OpenAI, but he also mentioned that now we have actually saturated in terms of the text we have available. We have actually used the entire internet. And so, yeah, we just need to find another way to scale and build more data that we can use for these systems.
Yes, I've seen that slide on the fossil fuel of AI going around a lot on social media, and I think it paints a really nice image. And yeah, I suppose the point you're making links back to the original title today, right? How to use agents to build a multimodal data pipeline. And essentially, what we're talking about is using the technology to build the technology, right? And so today we're here to discuss this notion of data agents. So previously, we've discussed the various different agents that exist out there and talked about the kind of types and the use cases of those. What makes these data agents different?
Yeah. So first of all, they are here to bootstrap our data building process, and that's their sole purpose. So we kind of constrain everything a little bit in that sense. And then the second thing is that they will, since they're trying to build data for us, it's very reasonable to think about how you separate responsibilities such that it becomes easy for everyone from a product manager to a data ops person to a machine learning engineer to actually understand what's going on in our projects and where are we in the project essentially. So that was basically the goals we had in mind when we were thinking about these data engines or data agents. Sorry, not engines. That's something different. Maybe that's the entire system. Who knows?
Absolutely, using agents to build engines. So some of those examples that we can see here in this workflow, right, where we're looking at kind of building out this pipeline using agents to kind of manage this structured data flow. We can see in the bottom like transcription, prioritization, pre-processing. I think it'd be cool to maybe discuss some of the use cases, right, that specifically we can use these agents for. So I know we've got a few on here, but Fred, would you like to add some color to how we can use these throughout our data stack?
Yeah. So there are essentially many problems we have when we're trying to build these large scale data sets. So first of all, we need to figure out what to use. For example, if you're building a video generation model, if you are trying to build the entire model on videos where nothing happens in the videos, then you're probably not going to learn anything relevant. So there's probably going to be some sort of, no matter what you're doing, there's going to be some sort of data curation aspect to it. So you might have to, employ a lot of filtering, employ a lot of heuristics to sort of gauge like how much is happening in the video, or does the audio stream actually contain any speech if I care about summarizing speech. There'll be many of these sort of heuristics you will be trying to employ such that you select the right data to begin with. Maybe you have data pruning strategies, all these kind of things. So that's sort of the data curation part. And you want to have it very easy to somehow inject that into the system. And every project is different, right? It's not like there's just one size fits all. It would be very different. Okay, so the next thing is that if we really want to scale these data set building approaches, then we will have to take humans as much as possible out of the loop while still having them in the central areas. So there are some things where it's just stupid. Sorry, pardon my language. That we employ humans since we can do much better these days. And we've seen this again and again in the lifetime of Encore as well. We've seen it like we introduced Sam a year or two ago, and that greatly sped up the speed at which you could annotate, such that you wouldn't have to draw every single pixel perfect thing, but you could resort to just refining the small edge cases where it didn't work. And these kind of arguments, sort of, there are many of those. So the idea is like take the human out of all the work that we can take them out of, and make sure that you include the humans when it makes sense. So it's like shifting the burden from annotation to, for example, review. To some extent.
Yeah, I think that's a really nice idea where if we think about data curation, right, those examples you gave, if you had a very, very long audio file or video file or even a text document, right, using these agents to extract the information that's relevant to the use case. And then rather than having somebody read through hundreds of pages of text or watch hours and hours of video or listen to hours and hours of audio, right? Kind of using these agents to speed up these flows and optimize them. And in the same on the annotation case, I like that kind of lineage that you drew from going from manual annotation, where somebody was placing polygon points around an object, to then using things like SAM to now kind of incorporate these models and having a human in the loop flow. And that's like a specific example, but all of these trajectories are pointing towards this agentic orchestration that we can see at the bottom here.
Yeah, exactly. That's the final part, right? You can also have agents actually orchestrate the workflows in the sense that they might be actually better at deciding who gets to see what piece of data. So instead of having a person sitting and routing data because something needs to go to an expert and others don't, then you can actually use agentic systems for that as well. Yeah. So we'll see like like a vanilla example, I would say. And I hope at least it'll sort of spark the imagination for what you could do within this sort of framework or setup.
Absolutely, yes. So we're going to kind of dig into the meat of the session now. And I'll hand over to you, Fred, to kind of take us through a demonstration of what these agentic workflows can look like. And stop my sharing. Yes, so while Fred is loading that up as well, if there are any questions from the audience, then please submit them through the Q&A at the bottom as well.
All right. So
Fantastic.
can you see my screen?
We can indeed. We can see your workflow.
Great. Okay, so this is one particular example. Suppose you are trying to, build a system or like a multimodal agent for understanding advertisement. So in a situation like that, you probably want to have, you know, these models understand both the audio content, what's being said in the video, on the advertisement. You also want to understand the video content as well. And so this is sort of a sort of thought example of what you could do. So you would probably want to have your data going into a system where you treat audio and video differently. So for that, we're going to inject a custom piece of logic that will just reroute video data to one data agent and audio data to another data agent. And then we want the audio agent to actually do a transcription of the data. And once it's done with the transcription, we might not want to use that audio anymore, but want to just assign the transcription to the video and then carry on from there. And for the video itself, we might want to have something like clip change detection to see how often does it clip the video, and maybe we want to treat every clip on its own. So that's the idea. And then at some point, the data flows to an annotation stage. Maybe we could even skip that and go directly to a review stage. But this is really the idea. And maybe one thing to mention here is you can set these things up exactly as you want. So you can drag in more of these agent stages. And so now what I want to do is I want to show you one more thing before we get started. So right now I can see my queue of all the things that has to happen. And what we notice here is that it's a composition of audio files and so MP3 files and MP4 files. And every video file also has an associated audio file. You can see all the tasks are here right now. So I would like now to see if all this stuff is ready. This is already satisfied. Fantastic. So now I would like to define one of these agents. And we're going to start, maybe I should just show that quickly. So we're going to start over here by just splitting out the tasks. So that's sort of the warm-up exercise.
So I think one of the nice pieces as well with these agents, and this was kind of a lot of the conversations that we were having at Neurix too, where people are having certain use cases they were needing to orchestrate or needing humans to validate and bring into this workflow. So once we've built these agents, then they can be repurposed and reused in different places as well. So, and then they can kind of grow in their scope and their understanding based on the different projects that they've been applied to. And so what we were looking at in the workflow builder is the kind of orchestration piece, right? So this is how we can join them up and build out this structured data flow. And then here we're looking into the kind of, into the engine side, I suppose, and looking exactly how the agents are working to bring this structure to our data.
Yes, exactly. So now we're going to sort of try to, define the logic of this flow, essentially. What's going to happen when a piece of data reaches the separate tasks agent node? So I'm going to copy the project ID here, and I can type that in here. There we go. I think it's the right one. So let's run this thing. So now I have this runner instance, and what it can do is it can run code on these different stages. So the first stage is this task routing stage. And now I'm going to jump back to the project, just make sure that this guy is copied. So I have the right ID. I'm going to put it in here. I'm pretty sure it's the right one, but just for the sake of exercise. So I'm going to say for the stage that has this particular ID, what I want to do is I want to look at the labels. The labels happen to have a property that is the data type. And if the data type is video, then I want to forward it through the video path. So let's come back here. So you can see there are two different paths, and I have chosen those. I have defined them. So there's a video one and there's an audio one. And if I see a video, I want to send it along the video route. If it's audio, let's send it along the audio route. Otherwise, let's just not do anything. There shouldn't be any of these in this particular project. Okay.
Yes.
So that's
This
the
this is
idea.
a nice example. Then, sorry, Fred, but this is a nice example of the curation agent that we looked at earlier, right? But like, also, I can see that this is quite a short piece of code. And for anyone interested, this is basically using the agents framework, which we've shown in a previous webinar as well. But the documentation is online too. That this is just a Python package, exactly as Fred is typing out now. But this is kind of available in the doc for that, accessible to everyone.
Yeah. And so now I have defined this thing, and I can reuse it for multiple projects if I wanted to. So I could do something like this: project hash equals whatever, and then it would run on that project if it shared the same workflow. But in this case, I already defined the project hash up here, so I think we're all ready to go. And then I can execute the runner, and I should, if I go back here now and go to the queue, I should see that now everything is gone from the separate task queue, and it's half of them are in the clip change detection. That's all the MP4 files, and the audio transcription ones are in the audio transcription queue here. Okay, great. I'm just looking at gazing at the time real quick. So wouldn't it be nice if we could, do some more meaningful stuff? And so I think one of the confusions we saw at NeurIPS was that people thought that this was just like off-the-shelf integrations with GPT-4o or Gemini or whatever. So here I actually wanted to show that you can actually just use your own thing or an open source thing if you want. So what I'm going to do here is I'm going to use OpenAI's so this is OpenAI Whisper. So Whisper is an audio transcription tool or a model. So I can load this model into memory. Let's hope that I downloaded it already. I think I did. And now I'm going to define a couple of things here. So let's actually let me just minimize these just for a second. So really what I want to do is I want to have a label row, so a place to store my transcriptions. And it's a bit weird because I'm looking at audio files, but I want to attach them to the video. And that's because I want to, as soon as I'm done with the transcription, I want to just, archive the audio and then keep processing the videos. Okay, so for that, I'm going to inject this. It's also a little bit just to show you that you can inject dependencies, I must admit. Okay, so essentially what I can do is I can say this particular function, it depends on this video label row dependency. And what does that thing do? Well, it takes our project that we're working on right now, and it looks for data that has the MP4 suffix, but otherwise the same title as the one we are currently operating on. And when it finds it, it reads the labels that are there already and returns the label row. And the reason why we initialize is because then we're also allowed to write to the labels.
Mm.
Okay.
And one of the nice things there is that doing this mapping, so kind of connecting between them, which we can also do using metadata that belongs to the object itself, is that essentially it allows us to work with this data multimodally within the agent too, right? So we can do this branching and structuring and organization. But we can also, if we wanted to annotate like events or pieces within the audio and the video, we can do this in the corresponding timestamps too, right?
Yes. Yes. And now if I had other functions that needed that depended on this relationship, I could reuse this function. So if I put this into another agent stage, I could, use the same thing. The second thing I need is going to be the file path. So I'm going to actually grab, now I'm going to remove this one. I'm going to actually grab the stored item from our storage, and I'm going to get a signed URL. So this is important for security, right? This is something that will expire. And so now I can read the data temporarily. And then I'm going to download it. I'm going to store it temporarily. Then I'm going to yield it. And this is because then when So the library understands that when the agent is done, then we are allowed to eventually delete it in the end. So we won't keep all these things on the file system, but only as long as we are processing them, and then they will get lost again, I guess. So that's the idea. So another dependency, and we have that here. So now it depends on the file path as well. So that means that now we can actually run the thing. So what it'll do is it'll download the file, get the file path. It'll find the associated video labels, and then we will call the model to get the transcription. We will create a classification instance, and then we should start seeing transcriptions coming in. And maybe one thing to look at over here is that if we go to the Explorer here, we can see right now there are, see if we have some transcriptions. There we go. So here we can actually see the transcriptions nicely rolling in for every one of the videos. And you could probably imagine now that this would just be like one step in the data pipeline process. So you could imagine that now we have sort of the transcription. What if we also did the clip change detection? And then we could run all that sort of aggregate information into a separate node, which would be some sort of summarization. Yeah, so that's really the idea, that you can compose these very easily, and you can host them in one place, or you can split them up into every single state, so you have a listener on every node, and data just flows nicely through the system. Yeah, did that sort of cover the idea of these data agents, Oscar? Are there any confusions?
Absolutely. So I can see a question from the audience that said, why did you use the model as an agent? As in, what is the final goal? So I think like in this case, we're looking to automate cases where we would previously have a manual annotator go in and extract, for example, like captioning, right? That was a whole industry where essentially people would go in and manually like transcribe videos or audio files. And so to be able to automatically imbue this text using an agent saves a lot of that process. But then having the framework to bring a human in to review and validate this output is kind of the key value here.
I think another good example is probably when you're trying to do video understanding, then you need some very, very sort of concise and detailed descriptions of what is happening in the video. And so you could imagine that this workflow would be even bigger. So first we would do, the transcription, maybe even as a function of the clips we detected. So we're going to transcribe every clip on its own. And we might even split the files right into smaller clips because they're easier to handle when we are doing training. And then within the clip, we might even want to have an LLM describe every, let's say, like a frame per second throughout the clip. And then we can use all these small descriptions to do one very, very concise description of the entire clip. And that way we can sort of, in small steps, build a data pipeline that ends up giving us what we really want before we train our own model, which is like videos, very, very concise and detailed summaries. And maybe somewhere in that pipeline, we also detect when nothing is happening in a video, and we can discard those. Right? So there are so many things that you can do once and for all without any humans. Yeah.
And as you said, that ability to be able to chain these together, right, means that in this case, in the same way that when you build code, having this modularity is so helpful for being able to reuse key functions that you go to again and again. To have these tasks that humans are having to constantly perform, to be able to A, automate them, and B, chain them together to kind of form this sequence, this structured flow, brings like a lot of power, right?
I think there's also a question of whether there are some off-the-shelf ones.
Yes.
Maybe I go to agent docs. So if you come in here, you will be able to find a bunch of examples. Some sort of example list is here. Like you can prioritize tasks, you can transfer labels, you can pre-label with predictions, and a lot of different things. and we are continuously building all these examples. So that is it is at least one thing you can do. Um, yeah.
Absolutely. Yes. Yeah. So these examples are kind of ready to go and be applied to these different scenarios. And then I think the other question from the audience is on, do we have any connections with Google Meet to analyze meetings, right? So um, directly, I think the way that we would go about doing that would be to utilize meeting recordings and kind of do this analysis. I'd be interested to hear what the specific use case was in that sense. I'm not sure if Fred, you've heard of anything interesting going on in that space.
Yeah, I mean, I think the value proposition there is of course extracting information of a particular type. We've seen it, across multiple apps already. Um, but yeah, we somehow try to stay a little bit generic or general in the sense that you can feed all these things into our system in multiple different ways. You can also even feed our web pages. And so then you can deal with your data. And maybe one thing that would be interesting to show also, I think we kind of uh, we should do that as well. So if I go in here and I were to annotate something, right, I could of course go in here and then I could edit the summary if I wanted to do that. Um, but one thing which is really, I think is really powerful is that if I go to these layouts, what I can also do is um, I can upload a layout file to determine what do I want to see next to each other. So if I come back here now with this layout defined, then I can, have a look at the audio and the video at the same time. So I can look at my transcription and I can listen to the audio if I wanted to do that. And there are even like more sophisticated use cases where you can set it up with documents or whatever it is that you need to sort of do your annotation task. Yeah.
Absolutely. Yeah, I think this one also links nicely with the kind of meeting example. You know, if you wanted to be able to analysis analyze text context from the transcript alongside the meeting recording and the audio too, being able to have this multimodal editor layout where you can look across all the different modalities and do this tagging live is helpful for both human annotation and review as well in this kind of human in the loop approach that we discussed earlier.
Yes, exactly. So the goal is to spend as little time as possible in here, I guess, as a human. But the time you spend in here should be of high quality and very performant. Yeah.
Absolutely. And then there's a question on scraping data from multiple websites. So we work with HTML as well at OnCall too. So one of the document modalities that we support is this HTML format too. So for tagging websites too, that can be super valuable. And then a question as well on Luma. Is that something that's considered open source and free library? And then a request to share the notebook, Fred. I'm not sure if you'll be making this available after the session.
Yeah, we can definitely make it available. That's for sure. And regarding Luma, I don't know.
Fantastic. Okay. So we are at time, and if there are any other kind of questions or interested in seeing on specific, there was a question about whether there is an open source offering by OnCall. So we do have a free version. These workflows are part of the team or enterprise plan. And so definitely get in touch if this is something that you're interested in trying. And also if you have any specific questions relating to individual domains or use cases too, we would love to hear from you. But with that, I think we can close out. Thank you all so much for joining and wish you all very happy holidays coming up too. And thank you so much, Fred, for joining today for kind of leading the session and for the demonstration as well.
Yeah, thank you as well. I think one last thing I want to mention is like, if you can see how your use case sort of fit into this framework, I would be very, very curious to hear about it. I would want to learn more, obviously, because I believe and hope that most use cases should. Yeah, so do let us know.
Fantastic. Okay, until next time, thanks everybody.